Hello everyone, welcome to my channel. In this lecture, we will discuss about the separation of carbon dioxide from methane with the help of Aspen adsorption. First of all, we will open the Aspen adsorption. We will go to the component and double click on the configure property. Click on use Aspen property system and click on edit using Aspen property. So it will take to the some time. We will go to the Aspen property system. And from the Aspen property system, we will add component to the Aspen property. And from the Aspen plus, we will add these component to the Aspen adsorption. So from the Aspen property, we will add this component. Now this is the Aspen property tab. Click on component. Here add the component. First one is methane, second one is carbon dioxide. Click on next. Now select base method. You can use ideal gas. I am using the Finn Robinson. Click on next. This is the temperature dependent binary parameter. Click on next. Click on OK. Now go to the Aspen adsorption. Click on OK. Go to the Aspen property. Click on yes. Again go to the Aspen adsorption and go to the default. Double click on it. Double click on these two arrow. Click on OK. Now after that we will make a process flow sheet diagram. Here this is the process flow sheet window tab. So this is the gas dynamic problem. Here you can see. So this is the gas speed, gas bed, and the gas product. You can rename. Right click on it. Go to the rename block. This is bed. Right click. Go to rename block. This is bed. Right click. Go to rename block. This is bed. Now connect bed with bed and bed with product. So go to material connection. Here go to the gas material connection because it's a gaseous problem. Add bed to bed and bed to product stream. Okay. Double click on feed and specify a feed. So it means what would be the temperature, pressure, and composition of the feed. So this is the model type is reversible pressure setter. Enable report is true and flow unit is in mole or mass. So it is mole. Now this is a feed and here you can see you can add the feed information. So suppose the feed is suppose 8 multiplied by 10 to the power 6 and suppose it is 0.68% methane and 0.32% is carbon dioxide. So is okay. Okay. The feed pressure is suppose it is 10 bar. Okay. Now this is information about feed. Now close this one. Close this one. Okay. So this is all about the feed. Now go to the product. Specify it. And the product, this is the product molar flow is free, it is okay. And suppose the product consists of 100% methane and 0% carbon dioxide. All carbon dioxide is suppose adsorbed and the product pressure is 1.01 bar. Okay. Now go to fit and specification, it is free, so we will fix this one. Fix this one. Okay. Now go to bed and it is there are one layer. There can be two layer. It is in vertical position and one dimensional. The adsorbent, click on this one. This is the material momentum, kinetic, isotherm, energy balance, etc. So we have information about bed, so we will add our saved file to this problem. So click on open. Here you can see when we here it show. So open your save file. If you click on this one, go to your save file. Here methane and carbon dioxide. Open this one. It will take some time. Okay, now close this one and click on bed. Here click on this one and go to the here. Material balance assumption is convection with constant dispersion. Momentum balance is Argand equation. The kinetic model is solid. Mass transfer coefficient is constant. The isotherm is the extended length bear 2. The partial pressure dependency is an isotherm. The energy balance is non-isotherm with gas and solid conduction. The heat absorbed is constant heat absorbed capacity, and there is adiabatic, no heat transfer to the surrounding, and there is no reaction. If you go to specify, so here you will see we have already specified these value. We have saved these value already, and now we open this file. So this is the bed height, bed diameter, the adsorbent density, the particle radius, etc. The mass transfer coefficient. Here is you will see various value like the constant adsorbed pass heat capacity per methane, carbon dioxide, the adsorbent specific heat capacity. Here you can see the heat of adsorption, the gas thermal the adsorbent thermal conductivity, the specific surface area of the adsorbent. So these are various values. And now we will go to the initial, and suppose initially there is favor methane in the bed and there is no carbon dioxide. This is a fresh bed. Suppose initially there is a fresh bed. Now close this one. Click on initialize. Click on yes. Now close this one. Close this one. Go to flow sheet. Check and initialize. Click on yes. No error found. Now here you see over specified by one fixed variable. So we will specify one fixed variable is over specified. So we will change, go to the product and one fixed variable. So this is a free. Okay, one fixed variable. Okay, we will change. Okay, we will change. This is fixed. This is also fixed. So we can change this to free. Okay, now go to the initialization and click on run. The run is complete. Now close this one, close this block, and now you will see this is feed, bed and product. Okay, now double click on bed and here you will see that whether our initialized is correct or not. So go to the initial, sorry, go to results, and here you see the bulk concentration within the element. So for carbon dioxide 000, it is okay. Mole fraction within the element, you will see mole fraction within the element. Okay, 1000, it is okay. Okay, close this one, close this one. Now this is new form. Click on this new form to plot various curves like temperature, pressure, composition, etc. curves. So this is a breakthrough curve. Suppose breakthrough breakthrough curve. Okay, now close this one. Again new form, uh, solid loading curve. Okay, close. New form, temperature, gaseous temperature curves. Close. Pressure, gaseous pressure in the bed, gaseous pressure in the bed, gas pressure in the bed. Close. Okay, you can plot other curves, but for this I will plot these some curves. So now go to the this button run option, and here change from initialization to dynamic, and at what time you will pause your simulation. So I want to pause my simulation at suppose 1300 second. 1300 seconds, it is okay. Now go to dynamic and here click on run. So it is the time start. Here you can see 1300 fast at 13. So click on this one and click on OK. Sorry, there is some, the time is now it is 2258. So there was some error. Now go to initialization, click on OK. Run is complete. Now again go to the flow sheet, go to check and initial, click on yes. Go to bed and check whether initialization is complete or not, because we want simulation at 1300 second and now it was 2000, about 2000, so we want at 1300. Now go to the initial results. Here you can see bulk concentration in the element, it is this. Now this is, there is some error. So okay, now click on this one, mole fraction, it is okay. Okay, bulk concentration in the element, okay. Okay, here go to the run option and 1300 is okay. 13, now it is correct. This check option, this must be tick. Oh, click on OK, and go to the dynamic mode. Here you can see pause at 1300 second. Okay, click on run. Now it will pause at 1300 second. Here you can see 600, 700, 800, 900, 1300. Okay, now here, now go to the flow sheet, go to form, is all available, click on this one. Okay, this is all available. Okay, okay, this is the flow sheet. Click on flow sheet, and here this is breakthrough curve. This one we have already made this curve, so double click on this one. Okay, breakthrough curves, this was breakthrough curves. Now this was breakthrough curve. Now click on this one and click on the bed. Go to result, and this is breakthrough curve, so it is for the methane and carbon dioxide mole fraction within the element. This is mole fraction within the element, and it is at last node. So the methane and carbon dioxide in the last node will be equal to the methane and carbon dioxide in the product stream. So this is okay, and this is for 1300 second. So you can also click right click on this one and click on full. So here you can see this is breakthrough curve for methane and carbon dioxide. Now right click on this one, go to the property, okay, and click on map axis, one for each, click on apply, click on OK. So here you can see this 1300 second is very long time. So if you want to axis, suppose I am changing it from 0 to 200 and click on apply. Even 200 is also very large, so I'm changing it from 100. Click on apply, click on OK. Here you can see this is the carbon dioxide is increases, and it increases to 38%, and the methane in decreasing from 1 to, here you can see from 0.003 or something. So 0 point here 0.68 it decreased to. So here you can see methane is decreasing, carbon dioxide is increasing. Okay, this is the breakthrough curve. Now go to pressure. This is in the flow sheet. Here you can see in the flow sheet. It can also be present in this flow sheet. Go to flow sheet, form. So here you can see the pressure curve. Suppose I want pressure curve, so click on this one, pressure curves, and now click on bed, click on bed, click on result, and click on pressure. So pressure within the element. Suppose the bulk concentration, mole fraction, solid loading, pressure within the element. Suppose pressure at the start, pressure at the center of the bed, and pressure top at the top of the bed. Okay, top of the bed. Close this one, close this one. Show zoom full. So here you can see zoom full. Now right click on it, go to property, go to the map axis, one for each, click on apply, click on OK. Here you can see that the time axis, maximize this one. Here you can see pressure decreases. Here you can see pressure decreases. Now this time is very long time, so I will change it from, double click on it and select, suppose I am changing it from 200, from 0 to 200, and the time window is suppose 200. 200 grid interval is suppose 20, and from 0 to 200 click on apply, click on OK. 200 is also very long, so I will change it from to 100. 100 grid interval is suppose 10, and the time window is also suppose 100. Click on apply, click on OK. So here you can see that the pressure inside the bed, the pressure inside the bed, pressure at 0, at 10, at 20. So pressure at 0, pressure at 0 was 10, pressure in the middle was, pressure in the middle was decreased, pressure in the middle was decreasing. Here you can see, and pressure at the top also decreases, but pressure at the top is small as compared to pressure at the middle, and pressure at the bottom is very long. Here you can see it is 10, this is 10, this is 9.998, and this is 9.99 something. Here you can see. So this is the pressure curve. Go to flow sheet, go to forms. Okay, pressure, go to flow sheet, form, and this is the solid loading curve. So click on this one, double click on column, click on it, go to results and solid loading. So here you will see solid loading, solid loading. So solid loading of methane and carbon dioxide. Suppose methane and carbon dioxide and methane, suppose in the center. What will be the solid loading of methane and carbon dioxide in the middle of the column? So this is the middle, and suppose I also want at the top, at node number 1. Node 1 is the bottom, node 10 is the middle, and node 20 is at the top. So this is node number 20. Here you can see methane at the top, carbon dioxide at the top. Drag and drop. Okay, maximize this one. Here you can see. Now the time here you from 1200 to 1302. So I will click on right click, full, zoom full. Here you can see the time axis is very long. So I want it for 100 or 150 or 200 suppose. So double click on time axis, and I suppose I want it for 200. Click on OK. Here you can see now this is right click on property, and here the map axis one for each. Okay. Now if you want grid, suppose this is the x axis grid, suppose line and marker. Okay, marker size, etc. Line and marker, no grid, suppose apply. Okay, so here you can see it found number 10, methane and carbon dioxide. So here you can see the solid loading at various point. So and this is the time, so double click on this one, and the grid interval is, suppose it is 220, suppose 20. Here you can see, so here you can see that at point number 10 in the middle of the column, the carbon dioxide, what will be the carbon dioxide, what will be the carbon dioxide, what will be the solid loading in the middle. So in the middle the carbon dioxide loading is increases. Here you can see the carbon dioxide load is increasing in the middle, and then it go and it become constants. And here you can see the the methane in the middle. So in methane in the middle is decreasing. Here you can see it is dissolving, it is dissolving. At point number one, the methane, here you can see the at point number one methane is dissolving and carbon dioxide is adsorbing. Here you can see, but at point number 10 the carbon dioxide adsorption is very large, as you can see. At point number 20 you can see, at point number 20 you can see methane is again decreasing and carbon dioxide is adsorbing, but its adsorption is small as compared to at point 10 and 1. So here you can see, because at point number 20 the molecule or the number of mole of carbon dioxide is decreasing as we go in the upward direction, so it is decreasing, the loading is decreasing. Here you can see. Okay, now go to the flow sheet, go to the form, a temperature curve, click on this one. Okay, again double click on bed, go click on configure, click on results, and this temperature is related to gas temperature with time inside the bed. What will be the gas temperature inside the bed? What will be the carbon dioxide and methane temperature inside the bed? So methane temperature at the start of the bed, what will be the, this is not bulk concentration, not the temperature. So go to the gaseous temperature, pressure, gas temperature. Here you can see you can change the unit, like if you want it in Fahrenheit, I want it in Kelvin, it is okay. So the at point number one, this is the gas temperature at point number one, the methane and carbon dioxide temperature at the start of the column, this one, the methane and carbon dioxide temperature in the center of the adsorption column, the methane and carbon dioxide temperature at the outlet of the adsorption column. Drag and drop, click on this one, maximize this one, right click on the curve on this, right click, go to the property. Okay, click on the x-axis map, one for each, click on apply. Okay, okay, now close this one. This is you can see this is the time axis, double click on it, and now the time is from 1200 to 1300, but we want it from 0 to suppose 0 to 1300. What will happen? 0 to 13, here you can see, but I want this, here you can see this is constant in this place, so our graph will be this 200 is okay, suppose. After that, because after this is a constant curve, there is no need, so 200 is okay. Grid interval is 20. Okay, so 20 multiplied by 10, it will be 200, there will be 2 10 interval. The time window is 200. Apply. Click on OK. So here you can see, you now right click on it, go to property. Here you can, this is the map. X is one, all power one. Suppose what will happen, all power one, one power each. Okay, grid, line and marker. Click on this one. Marker size suppose 5. Suppose I'm changing to 2, it will decrease. Here you can see marker size decreased. So 3 4 is okay. 4 is okay. Click on apply. Okay, it is increase attribute. Here suppose I want this one to this, and this is black, I want black one. This one to this one, and suppose I want this type, this one to this. Okay, click on apply, and here you can see this type graph. Now go to axis grid. The font size you can increase decrease. Grid, line and marker, like no grid. This one here you can see. So here you can see bed at this is at the, at point number 1, 10 and 20. At point number 1, here you can see at point number 1 the temperature is increases. At first it decrease, then it increase, the temperature increases, the gas temperature increases because adsorption is exothermic process. At point number 10 it is again first decreased then increased, 20 decreased and then increased. The maximum temperature for gases in this case is, here you can see 298. Here you can see 298 Kelvin. Okay, and here you can see this is non-isothermal process because 293, 286, 286, and this is 299, 298, etc. So this is non-isothermal problem. Okay, now again go to the blue sheet. The temperature, solid loading. Okay, loading curve. Click on full. So this was solid loading. Click on this. Suppose from, so this is solid loading curve. So we have already explained this one. Now I'm making some other plots, like go to the new, go to the profile plot. So this will not a function of temperature. So I'm plotting some other graphs along the height of the adsorption column. So loading in the height, what will be the loading of the adsorbate inside the column? So loading height curve. Click on OK, and now right click on this one, go to profile variable, click on find variable. Okay, click on browse. What this is block and this is stream. Click on block. This is bed adsorption column. Click on OK. Now browse what you are searching in the adsorption column. So I searching length. The length or height. This is length in the z direction, the z direction. So length, I want length, axial. So here you can see the bed axial distance. So this is axial or y direction or z direction, that don't. So the maximum length we have, we have already added. The bed height was 0.162. Here you can see. So this is okay. Change this one. This one. Okay. The bed height, this is the maximum distance. Drag and drop to this position and name it height. bed height, where you want bed height, bed height. Okay, bed distance or bed height. Okay, layer one. This is because there is one layer. Layer one is okay. If there were two layer, this will can be layer one, layer two. It depend on your problem. Okay. Now this is okay. Close this one, and now go to the bed. Bed. And this one, go to results. Loading along the height. We want loading along the height. What will be loading of carbon dioxide, methane inside the height with the height of the column? What will be the loading? So now this one, this one, this one. Now loading. Go to this one. Solid loading. This is solid loading. What will be the methane loading? How much methane is adsorbed at the beginning of the adsorption column, at the start point of the adsorption column? This is drag and drop methane, methane. Okay. Now you can also suppose I'm changing this one. This is okay. Is okay. I'm this now not at the start but the whole length. I'm changing from our whole length. Suppose methane for at point number 10. Methane, methane loading, methane loading, methane loading. This is point 10. So per whole column we will replace this with steric sign. Okay. Now click on this one or delete this one. So now go to the carbon dioxide, drag and drop this one, and carbon dioxide loading, loading. I want it for whole column, so I will replace the 10 with the steric sign. Okay. Height. Click on height, click on x-axis. The height is on x-axis and the methane loading is on the y-axis. This is y-axis, and the carbon dioxide loading is again. Click on plot and is on the y-axis. Click on apply. Okay, here you can see methane and carbon dioxide loading. The bed is on the x-axis. Okay. 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 Now double click on the axis, so it is 0 from 0 to 0.17, suppose, and the grid interval is 0 0.01. Apply. Okay. Okay. So it is okay. Now this is methane loading and the carbon dioxide loading. Okay. 1300 second. Okay. Now click on this one at 1300 second. Here you can see. So profile, go to time, was 200, 500. Okay. Cancel this one. I'm drawing some, sorry, this I'm drawing this plot again. So I will close, close, close. This one. Go to this form, flow sheet form, click on this one. Suppose I'm temperature, gas temperature with height. H mean height. Okay. Click on bed. Click on the specification. Click on the results and this one. Now right click, go to find variable. Find variable. Click on find variable. Go to browse. Go to block. Go to bed. Click on OK. Click on length. Again, axial distance is maximum axial distance is 0. This. Drag and drop this one, and this is height. Height. Okay. Now close this one. Now temperature. We will go to temperature. Gaseous temperature. After that we will go to loading. Solid loading. Temperature. Gaseous temperature. Suppose at 110. Temperature. Temperature. Okay. Okay. Gaseous temperature. The height is on x-axis. Temperature is on the y-axis. And for suppose at point number this is the timing axis, so at time 0 specify time. Click on this. This is suppose I want it for 200, so 0 50 100 150 200 apply. Click on OK. Okay, maximize this one, and here you can see, this is at a temp, this is a temperature at time 0, it is constant, and temperature at 50 second, the temperature of gas inside the bed is, here you can see, it is decreasing, so I will double click on this one, and I am changing this to 165. Apply, and this grid interval is suppose 0.01. Click on apply. Click on OK. 65. Apply. OK. Click on OK. Now here you can see uh, at 200 second the temperature decreases. The temperature of the gases decreases inside as we go along the height. The temperature decreases. Here you can see this is minimum temperature is below 290 Kelvin. Here you can see, and at time 100 it is slightly decreased along the height. At time 150 and 0 it is, time 150 and 0 it is 0, it is constant, here you can see